This is chapter 5, the series and the parallel circuits. This chapter has these important topics. 5.1 is about series circuit. 5.2, the current in series circuit. 5.3, voltages in series circuit. Session 5.4, multiple DC sources connected in series. 5.5 is about the parallel circuit. 5.1 series circuit. So as you can see, if we have two resistors and we connect resistors this way, so resistor R1 and R2 connected side by side, so this type of connection is called a series connection. In other words, the resistors are connected in series. Most of the time, we want to know what's the total resistance of the system. For resistors connecting series, the total resistance, RT in this case, equals to R1 plus R2's value. Let's see how can we connect two real resistors in series. This is one resistor, and here we get another one. We connect them together and they share a common point. So this kind of connection is series connection. Here we have more than two resistors connecting in series. So they are R1, R2, R3, and all the way to Rn, where the n indicates the index of the last resistor. Here we have n resistors connecting in series. The total resistance Req, in this case Eq is same as T. Eq means equivalent resistance, which is same as the total resistance of the system is the sum of all the resistance values. So this equation is a general formula of a n resistors that connect in series. It applies for two resistors connect in series, three resistors connect in series, and many resistors connect in series. Let's work on one example here. This circuit has three resistors connecting in series. They are R1, R2, and R3. R1 is 1 kilo ohm, R2 is 3.5 k ohm, and R3 is 4.0 k ohm. We want to know what's the total resistance of the entire circuit, the whole system. In other words, if we replace these three resistors by only one resistor, what's the value of that one resistor? So let's put the circuit on the side, and then we're gonna find the total resistance. First, let's write down the equation. There are three resistors connected in series. We only need three terms of that general formula. RT equals to R1 plus R2 plus R3. And then we just substitute the values. R1 is 1.0 k ohm, R2 is 3.5 k ohm, and R3 is 4.0 k ohm. Adding them up, the total resistance RT equals to 8.5 kilo ohm. Here is a special case. If we have n resistors, however, they all have same values, which means the first resistor's value is same as the second one, the third, the fourth, so forth. So they are same resistors, and we have n of them. The total resistance of this system is N times R. Here we have another example. As you can see, three resistors, R1, R2, R3 connected in series. They are same resistors. Each of them is 150 ohm. The question is, what's the total resistance of the system? So put the circuit to the side, and then we use the correct formula. We can use the general formula as well, but this one is easier. RT equals to N in this case equal to 3 resistors connected in series, times R. R is 150, so equals to 3 times 150 ohm. So together, the total resistance is 450 ohm. This 3 resistor circuit can be replaced by 1 resistor, and the value of that resistor is 450 ohm.